Okay, so now we're back at the book. We're talking about the mean. We already explained it, but perhaps the most important measure of location is the mean, or the average value for a variable. The mean provides a measure of the center, or they call it the central location. But the center for the data, right? The mean tells you kind of the center. If the data are for a sample, now we've talked about the difference between a sample and a population, I think we have. The mean is denoted by x bar. If the data are for a population, the mean is denoted by the Greek letter mu. Now, I'm going to pause here because I'm not sure if we talked about the sample and the population. So I'm going to just pause here. So let me just at least remind you or introduce you to this concept. So in statistics, sometimes we have a big population. Suppose we're talking about all the students at our university. But suppose I want to know the average height of all the students. Now let's say we have a total of 6,000 students. So we could actually go out and measure all 6,000 people and find their heights. We could denote it by x1, first student x2, x3. The first height is x1, the second height is x2, the third height is x3. We go all the way out to x6000. We could do that. And then we just do what we already discussed. We do sigma I equals 1 to 6,000 and divide by 6,000, right? So we could do that and we would get the average. But oftentimes we don't want to do so much work. And if the population wasn't 6,000 but 6 million, suppose we were talking about a whole lot of people, we wouldn't want to do that. So we can denote the whole population here. Maybe this is all the students. And we'll call that the population. And it has x1, it has x2, x3, it has x700, it has x5761, and so on. It has all the people in there. But we don't want, suppose, to do all the work of measuring everybody's height and recording all of that. So we will take a sample from the population. So we'll only take maybe 50 people or 60 people or 20 people or 100 people. But anyway, not the whole population. So we could I'll draw it like this. I'll say we'll take a sample. So we'll take a sample. So we'll call this the sample. So the population, let's say, we use the capital N to denote the size of the population. And let's say the sample, we use a small n for that, is 100. Okay, so suppose we have the sample of 100. Now it's easier to measure all 100 people's heights instead of 6,000 people's heights. So anyway, we have x1 here, and we have maybe x20 in there, and x5230. But whatever, we only have 100 of them. That's a sample from here. So we have 100 elements in here, which are drawn from the full population. And then what are we trying to do? We still want to know what's the mean for this whole population, but we're only going to calculate the mean for this. Now, obviously, the mean of this doesn't have to equal the mean of this. But anyway, we're going to calculate the mean of this. Now, I'm going to use this, it's not really right. I'm going to say it's x1 plus x2. I'm assuming like we got the first 100 people, we don't want to do that. But anyway, I'm just going to say this means the 100 people, and we're going to take 100. How do I erase? So we're going to take the 100 people and calculate their mean, and we're going to call that x bar, like we said. But for this, we're not going to use x bar. For the mean of the whole population, we use a different symbol. We use this symbol mu, which is, I think it's a Greek M. Mu. M-Y-U. Anyway, whatever it is, we're using that. So this is what we're trying to know, but we aren't going to actually calculate this. We're only going to calculate this. We're going to call that an estimate of mu. So x bar is called an estimate of mu. It's not, obviously it's not going to be equal to mu. It's unlikely that it's going to be equal to mu. It only estimates mu. And if we took a different sample, we would get a different x bar. That would still be another estimate of mu, but obviously they're not necessarily going to be the same, and they're not necessarily going to be the exact value of mu. When we're doing things from the sample, like here, we're calculating the mean of this, we don't use a Greek letter. We use a non-Greek letter like that. But when we're talking about things in the population, we use a Greek letter, and so we use mu.